All right, so we're going to go through the 1999 Calc AB FRQ number 3. All right, so in the table they give us information about R of T, which is the rate of water, which is the rate at which water flows into a pipe in gallons per hour. And then in part A, they ask us to use a midpoint Riemann sum with 4 subintervals of equal length to approximate the integral of 0 to 24 of R of D dt using correct units. Explain the meaning of your answer in terms of water flow. All right, so for 4 subintervals, we're going to divide 24 by 4, and that gives us 6. So we know we need to make an interval every 6 units, or hours in this case. So we start at 6 and draw a line just up to the point that we made when we graph the table values. And so 6, and then 12, 18, and then lastly 24. And so we have these intervals, and now we connect them to make, oh, 1 second, I had a wrong value in here. So we connect them to make these rectangles so we can approximate the area under that curve. So we just draw the line straight through the point that's in the middle of the other 2 points that we already have lines on. And then so we have these 4 rectangles, and then we just approximate we just find the area of these rectangles, and it should be, and then that'll be an approximation of the area under this curve. So to do that, we're approximating this integral so the area of this will always be width times height. So it'll be width times height. So all of the widths, because they're equal intervals, they'll all be 6. So we're just going to put 6 out in front and then add all the heights together and then multiply them by 6. So the first height is 10.4, and these are the heights of the midpoints, plus 11.2, plus 11.3, plus 10.2. And then once we add all of these heights together and then multiply it by the width of 6, we'll get 258.6 gallons. And then they asked us to explain that answer, so we'll just say this is the approximation of the total flow in gallons of water from the pipe in the 24-hour period. Okay, and then that's all of part A. So then we'll move on to part B. So we'll erase this. And then part B asks us, is there some time t on the interval from 0 to 24 such that the derivative of r of t is equal to 0? And then it asks us to justify our answer. So yes, there is a value of the derivative of r that equals 0, because r of 0 equals r of 24, and they both equal 9.6. The mean value theorem, I'm just going to abbreviate MVT, guarantees that there is a value that there is a t, on the interval from 0 to 24 such that the derivative of r of t equals 0. And then, so that question was just asking us to identify that the mean value theorem guarantees that there will be a value of r prime of t that equals 0. So we answered that question. Now we can move on to part C. So part C gives us this equation q of t that is 1/79 times 768 plus 23t minus t squared. And then the actual question asks us, the rate of flow r of t can be approximated by the equation q of t that we wrote down right here. And then it says, use q of t to approximate the average rate of water flow during the 24-hour time period and indicate units of measure. So for this, when you see something like average rate of water flow, you should instantly think average value theorem, average value. So for the average value, it's 1 over b minus a, so 1 minus 24 over 0, or 24 minus 0, times the integral from 0 to 24, because that's the whole time period, of this q of t function, dt. So then, if we just plug that into our calculator, we'll get that equals 10.785 gallons per hour. So then, this value approximates how many gallons are going into the pipe over the interval 0 to 24. And then it's in gallons per hour, and that's what it asks us for. And that's the whole question.